Welcome and hello. This is a video exercise in MODSIM, and in this exercise, we're going to be dealing with how hydrologic states affect reservoir priorities. In this exercise, we're going to create a hydrologic table, assign it to a reservoir, and then for each month of the simulation, a hydrologic state will be assigned to that reservoir that will affect the priorities and hence the water allocation. All right, so let's go ahead and get started. What I have on the screen is my MODSIM interface. We're going to start from the very beginning, and that begins with sketching out my reservoir network. I'm going to start with a non-storage node at the top, and then after that, I will have a reservoir, and then I'm going to have a couple consumptive demand nodes. So consumptive demand, click, that's going to be one. Here's another one, and then finally, the network's going to end with a sink. I'm going to go ahead and label these nodes. So for the non-storage node, I'll just call that NS1, move that to the side. The reservoir, I'll call that Res1, okay? And then move that label to the side. And then the first demand will be D1 and D2 for the second demand. All right, there are those labels. Let's go ahead and connect the network. This is just going to be flowing down. So the non-storage node provides the inflow to the reservoir, and then downstream of that, I will have the two demands, and then finally the network sink. All right, before I do anything else, let me go ahead and save this. I've navigated to my project directory here, and then I'll just name this, say, exercise 9, and then click save. Okay, so that's saved and we're ready to go. Let's go ahead and first define some of our properties here. So I'm going to start with the inflow. That is the NS1 non-storage node. I'm going to click on right click, properties. This is the properties box. So I'm just going to type in or paste in my flow values for inflow in this dialog box. And what I have prepared in a separate file is an Excel file. So I'm just going to grab my data for the 12 months of the year, Control C to copy, and then over here on the flow rate word, the table heading, I'm going to go right click and then paste column. All right, so that already came into place as I like it. In fact, I'm going to not vary it by year. So I'm going to leave this checkbox unchecked, which basically means these inflow values will repeat year after year. Every January, we'll have 16,000 acre feet for that month. Every February, we'll have 15,000 acre feet for that month, year after year. Okay, so I'm going to click apply and click OK. Speaking of the time duration, I'm going to update that as well. I'm going to go to MODSIM, Network Settings, and then for the time step tab right here, I'm going to use the 1 month time step. However, I'm going to extend this simulation to be 2 years, not just 1 year. So to do that, I'm going to click on the data end date, the year 1981. Then I'm going to click arrow up. It's going to advance to 1982. And then I also need to update the simulation end date right here. So I'll just click on the drop down and come down to the last record, which is the very end of 1981 or the very beginning of 1982. Same thing. All right, I'm going to go ahead and click apply. We are going to come back to this network settings dialog box when we set the run type to conditional rules, but not quite yet. I have a few more things to update in my network. So I'll click apply, click OK. Next downstream from our inflow is our reservoir, Res1. So I'm going to go right click and properties. All right, here are the reservoir properties. The general tab is what it opened me up to first. So I'm just going to type in some numbers here. The maximum volume of this reservoir is going to be 200,000 acre feet. I'll say the minimum value is 0. And then the initial volume will be 130,000 acre feet. And then the units, of course, is acre feet. So we can change that, but I'll leave it right there. The priority is starting right here at 100. And this is something I'm going to come back and change anyway. So just hang tight with that. All right, the next tab within the reservoir properties I want to edit is the runoff forecast tab. Here's the runoff forecast tab. Again, I want to leave this varies by year checkbox unchecked, so the data I type in here or paste in will carry over for both of the 2 years of our simulation. As before, I had copied the data for the runoff forecast onto my clipboard. It's the exact same numbers as the actual inflow, so we're assuming that we have perfect knowledge of the inflow. I'm going to go right click and paste column. Here are those numbers, and you can see that we have a new forecast for each month of the year. I'm going to go ahead and click apply, click OK to close the reservoir properties. I'm going to go ahead and now add demand data for D1 and D2. So we'll double click on D1. D1 is going to be a slightly higher demand, higher priority. I'm going to click on the general tab here and then change this priority from 100 to 90. Right. And then under the time series tab, because I'm using consumptive demand and time series for the definition type, I can click on time series. And then for the flow rate, this is the demand. I'm going to say it's 5,000. And then the units here are acre feet per month. I'm going to click apply and OK. That's all we need to do for our demand D1. And then demand D2 is going to be similar. In the general tab, I'm using consumptive and time series for my first two options there. And then the priority is going to be a little bit higher. I'm going to say it's 110, so it's a lower priority. It's less important to deliver the water to D2 than it is to D1. All right, let's see. Oh yeah, the time series tab. This is going to be the same volume. So a constant 5,000 acre foot per month demand to our node D2 all year round. I'm going to click apply and click OK. Now it's time to set up our hydrologic tables, and then that will dictate the hydrologic type that we assign to our reservoir. So we need to create the table first before the reservoir can reference that table. To do that, let me go ahead and click on the MODSIM menu and then Network Settings. Okay, so we're back here. This time for run type, as promised, I'm going to select the conditional rules and then click on the hydrologic state tab that opens up. Then click on create table. All right, so here is the table that we're going to create. Here's the name of it. I'll just call it H table 1. And then now we need to select the reservoirs that are going to be part of this hydrologic properties table. Our only option is reservoir 1. It's the only reservoir in our network, so that's fine. And then down here, we want to specify the number of states. I'm going to keep it at 3 states. The options are 3 through 7, but 3 is pretty simple. We're just going to have a dry, normal, and wet as our classifications for our hydrologic states. And then here for the boundary factors, I'm going to say they're the exact same for the entire year. So I'm just going to define this first row here, even though I can define multiple rows with updated boundary factors for each time period. So let me just delete those. Okay, so the first boundary factor is going to be between dry and normal, and I'm going to set that to 0.6. And then the second boundary between normal and wet will be 0.8. Okay, so we're going to break out the Excel and take a look at what this actually means. And we're going to do that in just a moment after I go back to my reservoir and assign this hydrologic table, H table 1, for my reservoir 1. So click apply, click OK. Here is the table. If I wanted to make edits, I can do it that way. Okay. And then I'm going to click apply here and OK. And then I'm going to open up the properties here for my reservoir 1. And in the general tab, I'm now going to select hydrologic table name, and that's going to be my H table 1. And now here are the different priorities. So before we just had a constant priority of 100, but now that we have 3 different hydrologic states, which is our 1, 2, and 3, or actually it's labeled 0, 1, and 2 in the index values, but we're just calling it dry, medium, and wet, or dry, average, and wet. I'm going to set the dry to 80, which means it's more important for the reservoir to not release water or to preserve water when the conditions are dry. And then I'll just leave it at 100 here for the normal hydrologic state. For the wet hydrologic state, we'll say this is 120. So keep in mind that the priority for our demand D1 was 90 and the priority for our demand D2 was 110. That means for a normal hydrologic state where the reservoir is at 100, then it's going to deliver the demand D1 water, that 5,000 acre feet per month. But if the reservoir is in a dry hydrologic state, it's not going to deliver that demand to D1 because the priority in the reservoir is 80. Priority at this demand remains at 90. Now for demand D2, its priority is fixed at 110, which means it's only going to receive water if there is a wet hydrologic condition, a wet hydrologic state, because the reservoir priority in that case would be changed to 120, and that number is larger than the 110 priority assigned to demand node D2. In addition to assigning different priorities for each hydrologic state, I'm going to click apply and then click over here on this Targets tab, we also need to specify the targets that are associated with those three hydrologic states. And since this exercise is not focusing in on the changing of targets based on hydrologic states, what I'm going to do is just set this to the same value for all three hydrologic states. So we still have a constant value here for our target, and it's not going to vary by year. So this is just the constant reservoir storage target. Let me change that back to January 1. Okay. And then I'll go ahead and click apply and click OK. All right, so before we actually run the model, what I want to do is show you that I've got an Excel file set up to help me understand what's going to happen so I can compare my expectations versus the model results. And I think this is sometimes helpful when you're learning a somewhat complex topic with a lot of moving pieces and parts, and also trying to make sense of some of the equations that we've read about in the user's manual. This exercise is created with lesson 15 in mind, which deals with reservoirs, conditional rules, and hydrologic states. So if you haven't watched lesson 15, it's recommended. I go into a little bit more detail about these equations right here. So the R value, the W value, and we're going to actually put this in action right now, as well as calculate the boundary values from the boundary factors. Okay, so let's break out the Excel. Here is the table I have created, and hopefully it's not too small on the screen here. But for each month of the simulation, on a 1 month time step, it's a 2-year simulation, so it goes down for 24 rows there. We know the initial volume in the reservoir is 130,000, and then these are the forecasted values, which we also provided, which is the same as the inflow. Now, we only have one reservoir in our hydrologic table, H table 1. So we know that this R value is going to be the sum of all the volumes of all the reservoirs at the beginning of the time step plus the volume of all the forecasts at the beginning of the time step. With only one reservoir, we know that it's pretty simple. It's just the sum of these two values. So what I'm going to do is come over here to column 17, type in an equation for my R value, which is going to be column 15 plus column 16. So the volume plus the forecast is 146,000 acre feet. The W value, this refers to the sum of the total capacity of all the reservoirs in our hydrologic table. Again, we only have one reservoir, so that's just going to be our 200,000 acre feet. Beta 1 and beta 2 are our boundary factors. So these are values that are multiplied by W to get our boundary values. The boundary factors, if you remember, were 0.6 and 0.8. So I'm going to type those in. And then to calculate the boundary values, that will be our boundary factor 0.6 times our W value. That is 120,000 for B1. And then for B2, similar deal. It'll be beta 2 times W. That is 160,000 acre feet. Okay, so what I did here with these calculations was basically just calculating the R value here, calculating the W value here. Again, check out that lesson 15 if you're interested in me going through it a little bit slower. Those boundary values were calculated using this equation right here. And now to determine if the hydrologic state is going to be dry, medium, or wet, we'll just compare our R value versus those boundary values. So to do that, I'm going to come over here to the state. Our options are dry, normal, and wet. So I'm going to write an if statement here. Okay, here it is. So it looks like it's normal. This is the if statement up here in the Excel equation. I'm basically saying if R value is less than B1, it's dry. If R is greater than B2, it's wet. Otherwise, that means it's between the two, and that means it is normal. 146,000 is between 120,000 and 160,000. So that's why this equation here for the state is returning normal for the first month of our simulation. All right. Now the priority here, this is going to be either 100, 80, or 120 based on the hydrologic state. So just over here to the right, I made a quick little lookup table. Boom, I just pasted in my equation right here. I'm taking the value of normal, that's the index or the lookup value from the first argument. Here's the array or the range of table values. Column 2 I'm trying to look up, and then false means I need an exact answer. All right, so that's why it's returning 100 for my reservoir priority in that first month, which means if we go back to MODSIM, if the reservoir priority is 100, then that means it will serve the downstream demand D1, but demand D2 is not served because demand 2 has a priority of 110. That's higher than the 100 of the reservoir. So let's go ahead and run that and see what happens. I'm going to click Save. Looks like it's already saved. And then click on MODSIM, run MODSIM. All right, looks like we're ready to go here. I'm going to actually zoom in on my model a little. I'm going to go right click and then graph the results from the reservoir. Okay, so here is the plot showing our results. All right, let's check out the reservoir volume now. So I'm going to switch this left axis label to volume. Okay, something's weird here. Let me figure this out. Something got goofed up. Hold on a second. So I'm going to go back to my reservoir properties, click on properties. Yeah, for some reason the reservoir storage values got reset down to 0 instead of what were they were at 130. I thought I saved that. Let me just redo it. So 130,000, 130,000 there, and 130,000 there. Okay, apply and okay. Hopefully this will work this time. Let me go ahead and run it. Let's go ahead and right click and graph. Okay, so that's sort of what I expected. Here we have our reservoir, and what we have is the flow is what I'm seeing on the plot here. The blue line represents the inflow, and then the orange line represents the release from the reservoir. So you can see that we have a minimum release of 5,000 acre feet. That's why this orange line is horizontal here for a number of months in the first year and also in the second year. And it looks like we suffer some sort of storage deficit because of this area between the inflow and the release. There's more release than inflow. So for a few months here and a few months here, our reservoir storage is going to probably dip below the target, but it looks like it recovered the following few months. So that's good to see that our demand D1 was met. I'm going to toggle over to left and then click on the volume. So up here at 130,000 feet, this is our starting volume in the reservoir, and it's our target volume in the reservoir for the entire simulation. The blue line here represents the actual volume of water, and it looks like it dips down to about 121,000 acre feet. Keep in mind the vertical axis just goes down to 121,000. This isn't an empty reservoir at all. It doesn't even get below 90%. I'd say that's about 93% of our target storage volume, so not too severe. And it looks like everything here worked as expected. One more thing I want to take a look at is the data. So if I click on this data tab, we were on the plot tab. Here's the data tab. I'm going to now expand this plus button and then click on Res 1. This is the table that shows us the start date, the mid date, the end date, some other reservoir parameters that we're not even using like spills, evaporation, loss. Here's the inflow right here. So those numbers we've seen. The storage release, this is the release from the reservoir. So you can see we're flatlining here at 5,000 acre feet for a number of months. And then during the wet period, we're releasing more than that. And then back down to 5,000 the second year. Over in the far right column, this is interesting. This is our hydrologic state. So it says 1, and that means we are in the normal hydrologic state for the entire simulation. Another table that I want to take a look at is the other one we have to look at, and that is the storage. So if I click on storage, now I have the beginning storage of the reservoir for the entire simulation. And it looks like it's stuck at 130,000 acre feet for most of the months in our simulation, except for a few here towards the end of the calendar year. Like here's the 121. This is the minimum value, and that occurs at the beginning of October. So just for fun, I'm going to go ahead and right click and copy the column. I'm going to come back to Excel here. And then in this volume column, this is the initial volume of the reservoir. I'm going to go right click and paste. Now I have values for all 24 starting months, the beginning of the month for all 24 months. And just out of curiosity, I want to confirm that the hydrologic state that I calculate here in my Excel is normal for the entire simulation. So let me just cruise through my equations. Okay, so that can copy down. That's constant. That's constant, constant. That can copy. That can copy. This can copy as well. And then, yeah, so all of these columns right here can copy down. So let me just drag them down to copy for the remaining months. And boom. All right. So as expected, the hydrologic state calculated to be normal for the entire simulation, which means the reservoir priority was 100, which means we never even tried to serve demand D2 because it has a priority set to 110. However, once we have a small enough initial volume and small enough forecast, that will result in a small enough R that is below this threshold of 120,000. That's when the hydrologic state is going to switch to dry. All right, so I've got a second scenario here, so we can move on and try something else. This is to create a dry hydraulic state scenario. And to do that, I'm going to change the demand in node D1 to something larger than 5,000 acre feet per month. Let's go ahead and switch it up to 10,000 acre feet per month. I'm going to click apply, click OK. Let's go ahead and run MODSIM. Yes, we want to save the changes. Okay, so that ran. Let's go ahead and take a look at the results now. I'm going to click on my Reservoir 1, right click, and graph. Okay, so we have a different looking plot here. Again, our target storage remains at 130,000 acre feet for the entire simulation. The blue line here is the actual reservoir storage, and it looks like it dips down to 114,000 acre feet. So before it only came down to about 120,000 acre feet, came down another 50% from its target storage. And then what I think happened is it was delivering 10,000 acre feet to D1. And then at a certain point right here, the hydrologic state changed to dry, in which case it was no longer trying to satisfy this demand D1. It made a little bit of a rebound. It went back. And then finally, the inflows filled up the reservoir. The hydrologic state changed back to normal. And that's when the D1 demand was served. That's, remember, 10,000 acre feet for this second simulation. Reservoir cycle started over and over again. You can see the pattern is starting to repeat year after year. Okay, so let's take a look at our flows. Here is the flow. The blue line here represents the inflow, so we've seen that before. The orange line represents the reservoir release, and as expected, we have a horizontal line here at the 10,000 acre foot per month mark. So this is where it's satisfying that demand, and at a certain point, this area represents a large enough deficit for our reservoir to switch over to the dry hydrologic state. And for 2 months here, towards the end of the calendar year, it looks like August and September, that's when the hydrologic state is dry. And the following year, it's, August and September. That's when it's dry again. Looks like we do have a little bit of surplus right here in, what is that, February and March. Okay, so that looks cool. Let's go ahead and check the hydraulic state in the table here in MODSIM, and then also check our calculations in Excel. So to do that, I'm going to click on the Data tab again, and then I'm just going to go to Res 1, and then to the far right of this table, we have all ones except for 2 zeros right here. That represents the dry hydrologic state, HS0. And then it's all ones again until we have, I believe this is August and September, October, November, December. Yeah, so this would be August and September of the second year. All right, so to confirm whether or not our calculations match, I'm going to, I have to open up the other table. That's this one right here. Here is the beginning storage. Oops. If you do a single left click on the column heading, it's going to sort the data by that column. That's definitely not what I want. I want to sort by the date. So I'm going to do a single left click on the date. Okay, just confirming that that's sorted. What I want to do is a right click here on beginning storage, copy column. I'm going to come back over here to Excel. Over here in the volume column, I'm going to right click and paste my values. Okay, so we have the updated volumes. The forecasts are the same. I have updated R values. It looks like for these 2 months here, it's less than 120,000, and that's why the hydrologic state returns dry. The reservoir priority changes to 80. No longer is it trying to satisfy that downstream demand, which has a priority of 90. So these 2 months of dry should also occur down here. Yep, in the second year. So that's August and September. Very cool. Okay, so what I'm going to do for a third scenario now is come back to my MODSIM and close some of these windows here. I'm going to change the D1 demand back to 5,000. But what I'm going to do is change the priority of the two demands. So here was 10,000. I'm going to change it back to 5,000. Click apply. And then for the general tab, I'm going to change this down to 70. Now 70 is less than the priority even when the reservoir is in dry mode. Remember, it goes down to 80, which means no matter what, it's more important to deliver that 5,000 acre foot per month of demand to node D1, regardless of the hydrologic state. So I'm going to click apply and then click OK. Now for D2, I'm also going to lower the priority number. So in the general tab, it was 110. Now it's 90. So this means the simulation will try to deliver that 5,000 acre feet per month of flow to D2 when the hydrologic state is either normal or wet, but not when it's dry. Okay, so I'm going to click apply and OK. Let's go ahead and see what happens when we run the model. That ran. I'm going to right click on Res 1, click on Graph. Okay, similar plot as before, but not exactly. Again, the blue line here is the inflow. The orange line is the release. And it's good to see that we have a minimum of 5,000 acre feet per month. It looks like we bottom out here for 1 to 3 months during the first year, and then another 3 months during the second year. That is what I assume to be the dry hydrologic state of Reservoir 1. And then it looks like we also have a noticeable horizontal line here representing 10,000 acre feet per month, which is the minimum to satisfy both demands D1 and D2, with a slight surplus right here at, what is that, April? Okay, so let's go ahead and check out the volume versus time. So here's that. And as expected, the volume of the reservoir is barely able to reach its target up here in April, where we have a little bit of excess flow. But it looks like we're really stressing the system here because it was barely able to recover. And the minimum volume got down to now 108,000 acre feet. So our first scenario was like 121, right about here. Second scenario was around 114, right about here. Now we're down to 108. All right, let's go ahead and check out the hydrologic states. So from that release, we assume that it's going to be dry for 3 of the 12 months in the year. Data, expand, res 1. Let me scroll over here. Here are our storage release values. And then on the far right column, we have our hydrologic state. So it starts off at normal, that's 1, and then dry for 3 months here towards the end of the calendar year, back to normal, and then dry again, that's the value 0, and then normal for the last 2 months. Okay, let's go ahead and paste in our starting reservoir storage values and confirm that our calculations are correct. Beginning storage is going to be right click, copy column, back to Excel, and then right here for the volume, I'm going to do a control V to paste. Okay, looks like that worked. And now I notice that I am dry for the 3 months that I expected to be, which is August through October. All right, for the fourth scenario, I want to modify the boundary factor. I want to change the lower boundary factor, which delineates the difference between dry and normal. In fact, I could just create a second table. Let's go ahead and do that instead. So I'm going to go up to MODSIM, Network Settings, and then click on my Hydrologic State tab. Here is my first table, which I have values of 0.6 and 0.8 for Res 1. I'm going to basically do the same thing, but change this dry value from 0.6 to 0.7. So click Apply, OK, create a new table. Now I'm going to say this is H table 2. It's going to include my Res 1. This dry beta 1 boundary factor I'll say is 0.7. And then the one between normal and wet will be 0.8. Apply, OK. Here's our second table ready to go. I'll click apply, and now I also need to go to the reservoir properties, and in the general tab right here, I want to update the hydrologic table name, and that is going to be table 2. So apply, and the targets, okay, that can stay the same because it's based on the hydrologic table right here. All right, so apply and okay. Now I'm going to go up to the MODSIM menu and run MODSIM. That ran. I'm going to right click and check out the graph. This feels like a more conservative approach because we're increasing the threshold on what is considered dry. Therefore, we're more likely going to drop the priority of the reservoir sooner in the year. And that's reflected right here in the storage plot. It looks like the volume in the reservoir only gets down to 120,000 acre feet. And remember, we didn't change the demands. We didn't change the demand priorities. All we did was change that threshold, that boundary factor from 0.6 to 0.7. So it's more of a conservative operation, and that's what we're seeing right here. Okay, so let's go ahead and change this left axis to flow now so we can see the inflows and the release. The inflows are the same. The release, you can see, it looks a little bit different. We no longer have a plateau at 10,000 acre feet anymore because I assume that the hydrologic state is considered dry before that time. And it's definitely considered dry right here where we have a constant 5,000 acre foot per month release. So just looking at this plot, I can only tell for certain that 1, 2, 3, 4, 5, 6, these 6 months out of the year are dry, but it could actually be dry a little bit before or a little bit after. That's my guess. Let's see what the data tells us. So I'm going to click on the data tab, the plus to expand, Res 1 data. And then in the far right column, it looks like the first 4 months are normal, and then 1, 2, 3, 4, 5, 6, 7. So the next 7 months after that, which would be May through November, and then the last month here would be December. That's going to be back to a normal hydrologic state for our reservoir 1. Okay, I'm going to go ahead and check out the starting volumes, beginning storage right here, copy, and then come over here to Excel. And then for the starting volume, I'm going to paste in the numbers. And something else I need to change right here is the beta 1. I'm going to change that to 0.7. So I'm just going to copy that down. Okay. Now the first 4 months is showing normal. The next 7 months is showing dry. And then the last month of the calendar year here is showing normal again. And that should repeat year after year. So here's the second year. Due to this 0.7 value, that means our boundary value B1 is now up to 140, which makes sense. So every R value less than 140,000 is going to get the dry designation. All right, let's do one more scenario and then call it good. What I'm going to do in this fifth and final scenario is to decrease the inflows and forecasts by approximately 70%. So what I have over in my Excel, here is the inflows and forecasts we've been using for the first 4 scenarios. I'm going to decrease that down to these numbers here, which is 70% of the original. Control C to put it onto my clipboard. Now let's go ahead and update how about our inflow data? Okay, so that's right here. I'm going to right click and paste column. So these are new values, apply and OK. And then for the reservoir, I'm going to go right click and properties. I want to click on the runoff forecast tab, go right click and paste column. Okay, these numbers are now updated and ready to go. So that's the only change I'm going to make. Let's go ahead and see what we get out of that. MODSIM, run MODSIM. Okay, now let's check out our reservoir data. So right click, graph. All right, here is the plot of our inflow in blue, our release in orange, and then let's check out the storage. So this is the volume versus time. It goes down to about 118,000 acre feet, again with a constant target of 130. And then as far as hydrologic states, we definitely have some dry months. So I'm going to click on Res 1, scroll to the far right. It looks like January and February are the only months of normal hydrologic state. Everything after that is state 0, which represents the dry period. There is a one right here, which I believe is, hold on a second, it's kind of hard to tell from this table if that's January or February. I think it's, well, you know what? Let's go ahead and just paste it into our Excel file and see what we get there. Collapse that. I need to get those starting reservoir volumes, which is right here, beginning storage, copy column, back to Excel. Okay, I'm back at my hydrologic table, and I'm going to Control V to paste in these numbers right here. Now, these are not the correct states because I also need to update the forecast values in this column. I have them on my clipboard here, so let me just Control and paste values. Okay, and then let me copy that down to the second year and paste values. Okay, so yeah, it looks like our calculator here in Excel is working, or at least consistent with MODSIM. So we have 2 months with a hydrologic state that's normal, and then the rest of the time it's dry, and then another single normal hydrologic state. This is the month of February of the second year. Okay, mystery solved. All right, well, that's it for this exercise. What we did was create a couple hydrologic tables, which were used to determine the hydrologic state of the reservoir, and based on that state, the reservoir modified its priorities either up or down. In our case, it was down some of the time to the dry hydrologic state. That modified the reservoir priorities and affected the flows down to our downstream demands.